Unit 3 Arrays. Define array, how to declare, initialize and access elements in array or single dimension array. Explain. An array. An array is a collection of same typed variables that are referred by a common name. An array is also called one dimensional array or single dimensional array. Single dimensional array shows one dimension either x or y direction. Array declaration, data type, variable name, size. Example is int a4. In the above, int represents data type, a represents name of array, size 4 represents number of elements in array. Array initialization and accessing elements. Array is initialized by as follows. The syntax is data type, variable name, size equal to list of values. Example is int a5 equal to 10, 20, 30, 40, 50. The above example one shown in the following diagram, that is A0 is 10, A1 is 20, A2 is 30, A3 is 40, A4 is 50. Either in horizontal direction or in vertical direction, A0 is 10, A1 is 20, A2 is 30, A3 is 40, A4 is 50. Accessing the third element A2 equal to 30. Define two-dimensional array. How to initialize, how to declare, initialize and access two-dimensional arrays. Explain. Definition: two-dimensional array shows two dimensions x and y. It contains same type of values stored in both x and y directions, that is stored in row, column, matrix form. The first index shows row and second index shows column. Declaration. The syntax of two-dimensional or multi-dimensional array declaration is given by data type, variable name, size 1, size 2. That is int A22, that is 2 rows, 2 columns size. Int B33, 3 rows, 3 columns. Initialization and accessing elements. The syntax of two-dimensional array initialization is as follows. Data type, variable name, size 1, size 2 equal to values. A22 equal 10, 20, 30, 40. So in first row 10, 20, second row 30, 40. Okay. Then next B33, first row 10, 20, 30, second row 40, 50, 60, third row 70, 80, 90. It is shown here like this. So in first row 10, 20 means A0, 0, 0, 1 because this is 0 and this is 0. Similarly here 20 means A01 is 0 and is 1. A0 and A1, that is nothing but the 20. Similarly here B00 is 10, B01 is 20, B02 is 30, like that. So in example 1, accessing of A00 is 10 and in example 2, B00 is also 10. Define multidimensional array. How to declare, initialize and access multidimensional arrays. Definition: multidimensional arrays can have 3, 4 or 5 or more dimensions. In arrays of 3 dimensions, the first dimension is called plane, which consists of rows and columns. Arrays of 4 or more dimensions can be created and used, but they are difficult to draw. Declaration. The syntax of multidimensional array declaration is given by data type, variable name, size 1, size 2, size 3 and so on, size n. So example is in A2, 3, 3. So 2 plane is nothing but 2, which consists of 3 rows and 3 columns. Initialization and accessing elements. The syntax of multidimensional initialization is given by data type, variable name, size 1, size 2, size 3, that equal to values. First row values, here it is values like that. So in each one two-dimensional matrix. Each plane consists of two-dimensional matrix. Each plane consists of two dimension. Here 0 is one plane, 1 is one plane, 2 is one plane. There are 3 planes are there. So each plane consists of two dimension. That is two-dimensional matrix. So row is values and first row the contains different values. Second row here see A322 means in first plane it consists of one two-dimensional matrix 10, 15, 20, 25. Then second plane which consists of two-dimensional matrix, that is nothing but 30, 35, 40, 45. Similarly, for third plane consists of again two-dimensional matrix, that is 50, 55 and 60, 65. So here first you take this 0, then 0, 0, 0, 0, 1, then 0, 1, 0, then 0, 1, 1, like that. Here you take first is 1, then 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, like that. Okay. So in the above example, the accessing of A001 equal to 50. What are different array applications? Explain. The different array applications are given below. Frequency arrays. One is, it consists of two arrays. One is numbers array, other one is frequency array. Now enter the values from 0 to 19 with repeated values in numbers array 0 to 99. So in 0 to 99, so enter from 0 to 19 with repeated values. Here that is 0 to 3 times. 0 is nothing but 3 times I entered. 1 is entered about 2 times. 19 is entered about the 2 times. Now count this and enter that count in corresponding frequency array. So that is at frequency 0, so the count is nothing but 3. In frequency 1, the count is nothing but 2. Frequency 19, the count is nothing but 2. Then histogram is a pictorial representation of a frequency array. To show the frequency of each number, we print a histogram in form of a bar chart. For example, the following figure is a histogram for a set of numbers in the range from 0 to 19. 0 to 19. In this hash star asterisks are used to build the bar. Each asterisk represents one occurrence of data value. For example, 0 only one time, 4. So here 4 ones were written, that means 4 stars. 7 twos are written, so 7 at 2 7 stars. 7 threes means at 3 7 stars. 18 2 18s means at 18 there are 2 stars. If you connect all these, it consists of the one bar chart. Random number permutation. A random number permutation is a set of random numbers in which no numbers are repeated. That is very important. For example, given a random number permutation of 10 numbers from 0 to 9, all are included with no duplicates. Let the first array contains the random numbers 8, 3, 5, 1, 7. So the second array contains a logical value 0 or 1. Here first value is 8. First value is 8. So put a logical value 1 at have random 8. Similarly, next value is 3. So put a logical value 1 at have random 3. Similarly, logical value 1 at have random 5, have random 1 and have random 7. All remaining places a logical value 0. This is shown here like this. Okay. So 0 means nothing, 0 is there at 3 and 5 and 7. 1 means, so 1 is there at 3. So that means at 3 you can put about the 1 like that. So strings. Explain about the strings with an example. A group of characters taken as a unit is called a string. Generally, strings are two types. They are fixed length string and variable length strings. Fixed length string represents the size of string cannot change it is fixed. Variable length string represents the size of string can be expand or contract to accommodate the data. For example, a person name that consists of only one letter or name that consists of 30 characters. Other than these, there two are length control strings and delimited strings. In length control strings, add a count that specifies the number of characters in the string. Using this count, we can determine the actual length of the data. In delimited string, the end of the string is represented by null. This is called as a null. Then in C, a string is a variable length array of characters with null character at the end. That is the definition for string in C. That the string is null terminated character array. That is nothing but in simple form. A string is in C programming, a string is null terminated character array. For example, if we want to create 5 character string, then we can write char A6 because in A6 5 specifies size of characters and 1 specifies null character at the end. For example, A6 equal to old, at the end there is a null. A string is also a list of characters enclosed in double quotations. Suppose here the compiler represents the null character at the end. No need to represent physically about the by ourselves. Explain about string input and string output functions with an example. For input of strings, scanf takes the blank space as end of the string and stop reading further. For example, if you used to read hello world using scanf, then it reads only hello because after hello there is a blank space. So if the string consists of only one word without a blank space, the function scanf may be effectively used. The stdio.h also provides the function gets for input and puts for output for strings. The example program is given by if you use the gets, okay, it's going to be read completely with these spaces. So enter text by giving space. If you want to read this text by giving space, then use about the gets. Simply the enter text is puts here. That means it's going to be displayed. So here we are not using any about the conversion character. Explain about arrays of strings with an example. A string is defined as an array of characters. A string is defined as an array of characters. If there is an array of string, then it becomes a two-dimensional array. That is char, var, name, ij. Or in simple about in case of pointer, you can specify char star identifier I. Because char star itself represents about one array, and identifier I represents another array that gives about the two-dimensional array. Where star is a pointer, I is number of strings, and j is number of characters in each string. The example is given by char name 38 equal to first, second, third. 3 because first 3 is nothing but number of characters. In each character, what is its size? Maximum size is nothing but 8. In char star name 3, you can specify only 3 number of characters, but in each character, how many in each string? 3 strings. Okay, 3. So in each, how many characters No need. Here you can specify whatever you want, but here you can specify only in each string you can specify only maximum number of characters is only 8. The example program is given by int I char star a array equal to 1 2 3. The different strings are how you can write for I equal 0 I less than 3 I plus plus percentages comma ai. Print about all strings. Suppose if you take without star, then you take about the two-dimensional array. Okay, so it will somewhat typical comparing to star. What are different functions for handling string characters with an example? So the standard functions for handling string characters are given by each digit, each lower, to upper, each alpha, each num. Each digit means check it is whether digit or not. Lower means lower character or not. Upper means upper character. Two lower means convert into lower. Two upper means convert into upper. Each alpha means check for characters, and each alnum means check about the alphabet and also numerical. So converting lower to uppercase, here A30 I0, interesting with the lowercase, then gets A, then uppercase string is A is not equal to 0, put char, to upper means it's going to be convert lowercase into uppercase. Then what are different string manipulation functions? Explain with examples. There are different functions that manipulate strings. These functions are called string functions. Then the most important string functions are given by strcpy s1 comma s2. It copies s2 into s1. strcat s1 comma s2. It concatenates s2 at the end of s1. Then strlen s1. It returns the length of string s1. strcap s1 comma s2. It compares s1 and s2. If s1 equal to 0, s2, then it returns 0. If s1 less than s2, it returns less than 0. s1 greater than s2, it returns greater than 0. strchr s1 comma ch, it returns ch character available in s1 string. At which point it will be available, at which place it will be available. Similarly, str s1 comma s2 means the s2 string where it is available in s1 string, s2 substring where it is available in s1 main string, it's going to be checked. strrev s1 means it reverses the given string. These functions use the standard data file string.h. The example programs are given by C program to implement string manipulation operation with library function hash include stdio.h hash include string.h into main char a30. Enter the string, get saved. Then length of the string is strlen a means it's going to be print the what is the length of the string, return 0. C program to implement string manipulation operation string comparison with library function. Comparison means first enter first string, then enter second string. So read in a one string, read in b another string. If strcap ab is 0, then string are equal, else string are unequal. Then string manipulation of length without library operation. Library operation means you take length carry a into I equal 0 while a is not equal to null I plus plus, return I. That means by using while operator, you are making about y plus plus return I. In here enter a string gets a. So the length of the string is just you write length a, then it print about the length. C program to implement string manipulation operation string compare without library function. So without library function int I equal 0 while a is not equal to null, a is less than bi return minus 1, else a is greater than bi return 1 I plus plus. So in this case enter first string, enter second string. If compare AB equal to 0, both strings are equal, else both strings are not equal. So explain different functions of strtod, strtof, strtol, strtold, strtol, strtoull with an example. The functions atoi, atol, atof shows that if digit characters are present in the beginning of the string, these are converted into numbers, but the remaining non-digital characters are lost. But by using these functions strtod, strtol, etc., the remaining portions of strings are recovered. strtod means it converts digital part of string into double. Then strtof means converted into float number. Tod means strtold, but return long double. Strtod is similar to strtod, but long double it convert into return long double. The strtol consists of three arguments. strtol represent unsigned long number, return unsigned long number, toull unsigned long number. Here T was 2016 4AB3 and one is nothing but the binary value, 03 is octal value. Here B and P 10 means it display about the decimal value 2016, and P16 means it display about the hexadecimal value 4AB3. 2 it display about the binary value 1101 so and so. Null comma 0 means it's going to be display about the remaining 0372. Discuss with the string to data conversion with an example. The string scanf function is called the string scanf function. Scanf function is called scanf. This function scans a string coming from a file. It requires a format string to provide the formatting parameters for the data. A scanf is a one-to-many function. It is also called. It splits one string into many variables. Example program means hello world 30, char name 20, age. Now suppose buffer percentage the name age means name value is stored, hello world name value is stored in name, 30 is stored in age. So output is also. The string printf function is called as printf. Okay. So this function write a string coming from a file. It requires a format string to provide the formatting parameters for the data. Yes, is many to one function. It is also called, it joins many pieces of data into a one string. The example program is there, A10, B20, C is there, C equal to A plus B is there. Here buffer comma sum of A and B means the sum of A and B and C both are is going to be combined, and it's going to be print, buffer means it's going to print about the sum of A and B is this value. That means here the sum of A and B and C both values are going to be combined and stored into the buffer, and that buffer is going to be printed. Write a program for Morse code. Morse code is a method of transmitting text information as a series of on-off tones, lights, or clicks that can be directly understood by a skilled listener or observer without special equipment. See here, int il char s30x, enter a string. So you store in s, then find about what is the length of the string for I equals 0 starting to ending. So you take switch. A means just dot dash break. B means dot dash dash. So whatever you want, you can write here dot dash or dash 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 like that. You can write about from A to Z. Okay, that means without suppose the person does not have eyes, then by using this dot dash lines, he can read about the text. He can read about the text. That is advantage of reading about the Morse code. Suppose if the person does not have eyes, then by taking it with his hands, okay, by finding about without seeing the eyes, dot and dashes are there. Then you can identify A, and dash dot are there, identifying B, dash dot dash is there, identifying about C. Like that, he's going to identify about the different characters of a sentences. Now, enumerated structure and union. Explain the type definition or type def with an example. The type def keyword is used to specify a new name for an existing data type. So, the type def keyword is used enumerated structure and union. Explain the type definition or type def with an example. The type def keyword is used to specify a new name for an existing data type. The declaration is type def data type new name. The example is type def int num means, so wherever you write the num, it's going to refer about the int. The example program is given by type def int num. The num abc means this abc are referred by the num. These ABC num are referred by the integers. That means int a, int b, int c. So that can be given as simply type def int num. A value is 10, B value is 20, and C equal to A plus B, and it will print about this sum. Explain enumerated types with examples. The enumerated type is a user-defined data type for integer data type. So user-defined data type only for integer data type. In an enumerated type, each identifier is an integer value, and it is nothing but a constant. The keyword used for enumerated type is enum declaration. The declaration is given by enum type def type name identifier list. So in this list, all are nothing but the integers. The example is given by enum color red, blue, green, white. All red, blue, green, white is referred by the integers. In this example, each identifier is an integer value. That means red is referred by 0, blue is referred by 1, green is referred by 2, and white is referred by 3. Operations and enumerated types is given by the declaration, and assigning values are given by, already we know, enum color blue, green, white, three colors. So enum color X, enum color Y, enum color Z. X, Y, Z also integers, blue, green, white is also integers. But X value blue, it is taken as 0, it is taken as 0, it is taken as, see here, enum color blue, green, white means enum color X, enum color Y, enum color Z. Now X equal to blue, that is taken as 0, then Y is green, that is taken as 1, then Z is white, that is taken as y. White is taken as 2. Okay, because in color blue, green, white, 3 are nothing but the integers, and X, Y, Z is also integers. That's why these integer values are taken as X value is nothing but blue and 0, Y value is green 1, Z value is white 2. The comparing the enumerated types. The enumerated types can be compared using the comparison operators. For example, given two color variables, we can compare them for equal, greater than, or less than. For example, if color 1 equal to color 2, then it checks whether color 1 and color 2 both are equal or not. If color 1 double equal to blue, then it checks whether the color 1 is equal to blue or not. Similarly, color 1 is less than blue, then it checks whether color 1 is less than blue or not, like that. Example program hash include stdio.h enum week, that is taken as mon tu wed ta fry sort sun int main enum weekday day equal to Wednesday. So that means day means what it will print. Wednesday is nothing but 0 1 2, it will print about 2 to the output to the output to the above program is 2. Explain about different derived types. The derived types are arrays, functions, structures, pointers, etc. An array is a collection of same type of variables. A function is a subprogram. A structure is collection of one or more variables of different data types. A variable is that stores an address of another variable is called pointer. Define structure. Explain how a structure is declared with an example. A structure means collection of one or more variables of different data types grouped into one. The syntax is structure tag type member name 1, type member name 2, type member name n, structured variables. Example is struct student, char roll number 10, char name 30 int marks. For the above structure, memory allocation will be as follows. Char roll number 10 means up to each character 1 byte. So roll number 10 means totally 10 bytes. Char name 30, each character is 1 byte. So char name 30 means 30 bytes. Int marks, each integer 2 bytes. So totally 10 plus 30 plus 2, 42 bytes. Explain structure initialization and accessing structures. The structure initialized in main function. The members of a structure can be are accessed by dot operator. So struct ABC int a float b is taken yes. Now you can take the values s dot a equal 10, s dot b equal 20 and print these two values. In the above program structure, variable s is structure, members are a comma b. So we are initializing as s dot a equal 10, s dot b equal to 20.5, and it can be accessed by s dot a value and s dot b value. Explain nested structures with an example. A structure inside immediately another structure is called as a nested structure. The example program is given by hash include stdio.h struct abc int a, and one more float b can write in another structure struct def float b, it is taken as n, and total it is taken as s. Now for first value you can access directly s dot a because in struct abc only int a is written, but for second value in struct abc inside struct def you are written, that means s dot n s dot n dot b s dot n dot b equal 20.5. In the above example, abc is outer structure and def is inner structure. Refer inner structure first, refer outer structure, then next inner structure, that's why s dot n dot b. Then explain arrays of structures with an example. To declare an array of structures, we must define a structure and then declare an array of variables. Struct ABC is one structure, array is nothing but S2. This creates two set of variables defining the structure S. Two variables. So here int a S2, two variables, it can be 2 means two variables, that is S0 dot a equal 10, S1 dot a equal to 20. Now you can print about what is the S0 dot a value, S1 dot a value. Explain structures and functions with examples. It can be passing structure members to functions. Passing structure members to functions. So we can pass structure members to functions. Then structure members to functions means you take int a int b s. Now here you write function int a comma int b. That means print about a value, print about b value. Now you take s dot a value so and so, s dot b value so and so, and pass to the function display s dot a comma s dot b. So s dot a equal 10, s dot b equal 20, display s dot a comma s dot b means it can pass here s dot a and s dot b value. S dot a refers 10 comma 20, and here display 10 comma 20 is going to pass, and 10 is going to print it, 20 is going to print it. In the above program, two members values s dot a, s dot b are passed to display method when this method is called. Passing structure to functions. We can pass structure to functions. Consider one structure, structure student int a int b. Now take about pass about this structure s to display function, then print s dot a s dot b, and here you write about that structure struct student s dot a is 10, s dot b is 20, display x. So you are directly passing about the structure to display function. In the above example, structure variable s is passed to display method when this method is called. Explain pointers to structures with examples. Pointer to structure, same procedure like previous. Struct student s, only difference is Here you write x where reference here you write and you write star s. Two variables you write, and if you want to print the values s arrow mark a, s arrow mark b. Then define s dot s and s equal to and x. These are important. For and x you write here x. Now s arrow mark equal to 100, s arrow mark b equal to 200. Then display s means it going to print about the, it going to pass about the s arrow mark a, s arrow mark b to the structure star s and print about s arrow mark a and s arrow mark b values. In the above program, the structure members are accessed by S arrow mark A and S arrow mark B. Explain union with an example. Unions are similar to structures. The syntax of union is also similar to that of structure. The only difference is in terms of storage. The structure allocates separate storage space for all its members, but the union allocates one common storage space for all its members. The general form of union is shown below. Union tag, type member name 1, type member name 2, and so on. Type member name n. Union variables. The example of union is given below. Union student, char roll number 10, char name 30 into marks. For the above union, only 30 bytes of memory will be allocated since char name 30 will occupy maximum space of memory over others. So in over others, which is the maximum, 30 is the maximum. So this 30 can be shared by the all. Total memory allocation is 30 bytes. Differentiate between structures and unions. Structures. Structure allocates storage space for all its members separately. Union allocates one common storage space for all its members. Structure occupies higher memory space. Union occupies low memory space. Structure, we can access all members at a time. We can access only one member at a time. Example previous. Student, char roll number 30, char name 30 into marks. Union student, char roll number 10, char name 30 into marks. For the above structure, memory allocation will be like below. Char roll number 10, like 10 bytes, char name 30, 30 bytes into marks 2 bytes. Total memory allocation equal 10 plus 30 plus 2 equal to 42 bytes. For above union, only 30 bytes of memory will be allocated since char name 30 will occupy maximum space of memory over others. Maximum space it can allocate. So maximum space it occupies. That's why that maximum space can be shared to all. We all, in other words, in char roll number, char name into marks, which is the maximum, name 30 is the maximum. So this 30 can be shared by the all. So total memory allocation equal to 30 bytes. Total memory allocation equal to 30 bytes. This is going to be completed about the unit 3 in simple format. In